What the answer for yesterday? What were you looking for? Like comparative. Got it. You're getting the expected out in that sense. The comparative design and all we are going to see in the higher courses, but I don't know. I mean, how many of you will be opting for that course? Yeah, I mean, this comparator and all, one course will be common, like, but you will be looking at in the black box point of view, like op amp and all. But if you want to really learn how to design it, then there is a separate subject that may be an elective. It's called as a CMOS design. I taught it last year to NIT at VNIT Nagpur. It was like very nice subject. That will give you many insights into how actually the ICs are designed, what is there inside an op amp, differential amplifiers and a lot of things. So, all right. So let's begin. I think yesterday we have seen this shift resistors, right? Let's go for once we are known how to design. Once we know how to design the shift resistor, we can always go for counters. So let's see counters. Now again, counters can be designed in various modeling by using various models. Usually we'll go for simplest possible case, which is called as a behavioral modeling. So using behavioral modeling, it's much simpler. So behavioral modeling. Counters are like very simple to design. So what you can do is you can simply write module. The counter. Now what do you need to count? I mean, see, how was the counter? Now we know, like in behavioral we'll treat this counter as a black box. Alright. So assume that it's a counter which has some clock age. Now this age may be, now again I'm not drawing this flip-flop, it's an array of flip-flops. I'm saying that it's a counter. The counter may be positive age trigger or negative age trigger. I'm drawing it as a positive age trigger. At the output, what I want is, like, now it may be any bit counter. So I would prefer like a 4-bit counter, which would have the lines ranging from MSB to LSB. So let this be Q3, Q2, Q1 and Q0, and this is clock. See, I'm not going to the structure of this counter. So let's say it is a up counter. So I'll say it as a up counter. So 4-bit. So what are the inputs required? We hardly need any input, right? I mean, we just need a clock, and it should count. I mean, we are not taking care of that reset and preset and clear. Of course, we can have those inputs also, but what we'll do is we'll just design a simplest possible case of a counter, something like this. I mean, at each and every edge, it should simply increment the count. So it's very simple. Like, again, I'm saying that we are avoiding the structural design. In the structural design, we would have 4 such flip-flops connected one after the other. You know this design, right? I mean, how the design would be, you know it, right? You would have 4 different, which flip-flops? How the structure would be inside this? 4 flip-flops. Which flip-flops? Any flip-flop operating in toggle mode. So we would have 4 flip-flops. Just because it's a positive age triggered, we'll have a. Now again, the counter may be synchronous or asynchronous. Here we will go for a ripple counter. Yes, please. Topic. We are designing counters in Verilog. We are going for programming. Yes. Structurally, we should specify like how the outputs are connected to the inputs. But here, behaviorally, we don't need to. So that's what the difference between the structure and behavioral is. You don't need to specify how the outputs and inputs are connected and so on. So I'll simply draw the structure just for reference, which we are not going to use. positive edge triggered clock, and this q bar, q bar, and so on. We are taking the output from this non-complemented terminal. So the output I am taking it from here. Remember this structure? What counter this is? It's a 4-bit asynchronous positive edge triggered up count. Okay, yes, good. What is this? A T, right? T. The thumb rule to remember is, like, if this is like a up direction, it's an up counter, but for positive edge trigger. If it is the linings are like down, then it's a down counter, but positive edge trigger. If it is negative edge trigger, then the reverse is true. But we always take output from the non-complemented terminals. All the T's are connected to all the T's they are connected to 1 and there is only one clock. So clock and T equals to 1. That's it. This is Q3, Q2, Q1 and Q0. Alright, so what I am saying is, let's take a simple case of this counter. See, counters may have some initial value. Now say the initial state I am assuming it to be 0. That will have to specify, otherwise you will get high state and it won't be able to count. So let's go for, these are both the modelings which are possible for the counters. So what I am saying is, this is a behavioral modeling. Structure. In structural, we have to take care of the inputs and outputs. In behavior, we don't need to. What is the behavior of this? We know the behavior. What is the behavior? How can you describe this in one line? If I ask you to define this 4-bit positive edge triggered up counter, how will you define in one line? As the next positive edge comes of a clock, as the next positive of clock appears, the count will be incremented by 1. That is the single line description. But yeah, so that is what the description in behavior. In structure, we'll have to define what flip-flops to use, how the connections are made and so on. Let's go for design in both ways. Okay, let's go for behavioral first, just because it's quite simple. Go to edaplayground.com. It's much simple. So what is the usual procedure? Step 1, define module. Just because in behavioral, now first you should write the name. It's like we are defining up counter. So positive edge triggered up counter. How much bit? 4 bit. 4 bit. Which modeling? Behavior. Okay. I'll define module, module name, let's say it's a counter, so CNTR, or I'll give some meaningful name, positive edge triggered up counter. Okay, let it be counter, CNTR. Inputs, clock, output. Well, output is nothing but a single, a vectored output, right? Q3, Q2, Q1, Q0, right? Q semicolon. After that, input. Which are the inputs? Clock. Output. Output is a vector of 4-bit, right? So we'll have to define that in. So output, it's a 4-bit vector ranging from 3 to 0, Q. That's it. Then What is the behavior? As I said, as the clock appears, when positive edge, right? When positive edge of the clock appears, it should simply increment the count by 1. That's it. So always when at the rate when the pos edge of clock appears, what you need to do? Simply need to increment. What do you need to increment? Q by Q plus 1. That's it. By default, as I said, these numbers are taken in decimal. Okay, they are like, just because users are familiar with decimal numbers, they assume, the compiler assume that I have given it as a decimal equivalent. If you need to specific, if you have to be specific about the radix, you can specify it something like this: 1 digit binary 1. Okay, you can provide that in hex also. In hex it will be the same. Okay, 1 bit H will be hex. So I'll simply write it 1. I'm simply avoiding all those jargons, unnecessary things. But and end module. See what is missing? Huh? Yeah, so Q is given, but we need to, just because it's a part of procedural statement, we have to define it as register, right? So reg Q, which is a vectored again, 3 to 0. That's it. What else? That's it. That's it. I think that's it. Okay, everything is fine. Well, now see, okay, let's go to the test bench. Now see this Q, we are assuming some values in the counter. Okay, I can define some initial value. Okay, let's directly go for with this, whatever the basic structure is, then we'll modify it. Modules, test bench, module CNTR underscore TB. I'll simply copy these things. I don't need this arguments. Input, clock has to be varied, so that has to be reg type. Output, that's fine. Then tell me, instantiation, copy this, paste it here, give the instance name. After that, bolo initial, begin. In that, what do I need to vary? Just clock. That's it. Clock, initially I am keeping it as 0. After, let's say, 2 units, I am simply complementing it. Complement of CL. That's it. This is okay. End module. That's it. Yeah. Huh? Yeah. Sorry. So we need to repeat this. Repeat. How many times? Let's say 10 times. Let's see how the count would appear. Is this okay? So we have defined a module called CNTR, in which input is only the clock and output is nothing but a Q, which would increment. What is the behavior of this up counter? It will simply increment by 1. You may increment by 2, 3, 4, whatever you want to. If you want to decrement, you simply write minus there. If you want to go for both up and down counter, then we can specify if there, and we can specify a control pin where we can specify it is a up counter or down counter, and so on. That you can do. Hope this is fine. It should run. Let's see if it pops any error. You need to select this proper compiler. I will select this iCaris Verilog 0.7 recent version. Open pview for run. Rarely happens that it will. Okay, it's already declared here 2. Alright, so test bench underscore TB, I forgot. It rarely happens that it will run without any warning or error. Did it happen with you? I mean, click program को एक भी उसके, you didn't modify a single time, it ran in single. Very good. It didn't happen with me. So you are much trained than me. So test bench 12. Let me see if there are any errors. what is the error? Yeah, semicolon. So as I said, it won't happen with me, so fine. Yeah, exactly. I'm missing some important thing. After initial begin, dump file, because I'm quite curious to get the output, so I will always run to execute it. Dump file cntr dot vcd dump vars. I think it should run now. Yeah. So, oh, you won't get the output. Great. So, I think the initial value of q is not defined here. See what is happening here? Everything is working fine, but you won't be able to see this just because here, if you change the radius to binary, it's xxxx. That means don't care. Just because we didn't feed any output, we were not having any initial value there. These states are constant, are not changing. I mean, even if you increment xxx don't care by 1, it will be don't care. So we'll have to specify what would be the initial value of that q. You can very well specify that using here, right? Anyway, it is defined as reg. So what I can do is, I'll simply specify that initial value as, let's say it is 0. Then it would increment. If I run this, yeah, I should get this incremented. Okay, I'm getting this incremented output 0, 1, 2, 3, 4, 5. Try implementing down counter using negative age triggered and so on. Go for it. This is very simple, isn't it? Very simple. You just need to specify one line here. This is what is called as a behavioral modeling of 4-bit positive age triggered up count. Now here I didn't specify the flip flops. The thing is, like, here you can't select what kind of flip flops to use. Here you can't select is it a ripple counter or a synchronous counter. Here we can't do that. For that purpose, we'll have to go for structural modeling. So once you are done with this, go for structural modeling of 4-bit ripple up counter using T flip flops. Now that's a complete specification for structural modeling. So implement this. I'm going for, let's say, a 4-bit counter, but in structural way. Everyone got this? Understood this? Go for structural modeling of this. For structural modeling, you will have to define first. क्या define करना पड़ेगा बोलो? Structure देखो कैसा है इसका? What is this? How is the structure of this 4-bit up counter? There are 4 such flip flops, T type of flip flops. So first we'll have to define flip flop, T flip flop, and then we'll have to connect those, right? Let's do it. Module, bolo, TFF, TFF, input bolo, T, clock, output, Q. You need to design these counters using both the modeling, okay? Input T CLK, output Q 0. I'll keep some initial value as 0. How is the T flip flop defined? Always add, I'm assuming it to be positive age triggered, pos age of CLK. What should I write it here? If T, it should give me Q should be retained, right? Else be complement, no? If T is 1, or else Q should be retained. That's it. Is this okay? After that end module. This is the module definition for T flip-flop. Now once you have defined this T flip-flop, you can very well use it. How to use it? In some other module by creating an instance. Module CNTR बोलो inputs only clock, output Q, enter, input CLK, output. Now output is a wire, right? A vector. I mean each of them are connected to individual flip-flops. So I'll have to make it as a vector 320 Q. Alright. Again, in addition to this output, I will have to specify that as a, here I can't specify this directly as 0. I will have to define that as a reg, then only I can specify. So reg. Why reg? Anyone? Why reg? Yeah. Yes. Assignment here, I mean Q is assigned some value in procedural statements. Whenever that happens, see, wire can't hold the value. Wires can't hold the value, so we'll have to specify them as reg. Because we have to save, we have to retain that value till the next change happens. Alright, CNTR. Now, we need to use this already defined module. How to do that? बोलो syntax. ये यहाँ का ये उठा लो. Tell me what is missing. What is missing? Yeah, instance name. Now you should not say module because we are using that module. That means we are creating an instance. So it is TFF. कौन सा bit रहेगा ये? बोलो MSB और LSB. LSB ना? LSB right? See here. It's a ripple counter. ये कौन सा bit है बोलो? ये flip flop. Which one is this? Now this is not Q3. Oh wait. What should I write it here? Q0, Q1, Q2, Q3. Why? Why? Tell me. Rachita? Rachita, no? Tell me. Initially I wrote Q3. I am writing Q0 now. Why? Aisha? Why? Divishri, tell me. Saurav? How? Why LSB? अच्छा left से इसलिए अच्छा clock, yes. So clock is been applied here first. So more frequently this is getting toggled. So the bit which toggles more frequently, that is LSB, isn't it? See, I mean 0001, 1011. If these are the bits, which column is toggling fast? This one, right? It is 00, then it is becoming 11. It is 0101 fast toggling. So that's why it's a LSB. All right. So let's go for now. After this, tell me the input should be. बोलो T को क्या देंगे? 1. Yes, very good. It should be 1. Q का क्या आउटपुट रहेगा? ये 0 ना? Q0. I'll simply copy this, paste 4 times. Q0, Q1, TFF2, TFF3. इनपुट सबको 1 1 1 1 रहेगा. बट क्लॉक जो है, क्लॉक क्या एक्ट करेगा? इसको बोलो. व्हाट शुड आई राइट इट? क्लॉक. यस, The output of this will act as a clock for the next, right? So I'll replace this with Q of 0. Is that okay? Here, बोलो यहाँ पे क्या रहेगा आउटपुट 1 2 2 here यहाँ पे बोलो Q 1 यहाँ पे Q. Everyone got the output for the previous one behavioral वाला आउटपुट आया सबका? किन लोगों का नहीं आया आउटपुट? नहीं आया प्रीवियस वाला behavioral वाला. You need to execute that. Okay, once you execute that, then only you have to run this. After this that's it. End module, write the test bench module cntr pb. I should not specify any arguments here. So reg clk output three to 0 q. Yeah, then instance name cntr inst. See, this is again an instance name. Okay, I have simply written it as tff, so better way I will write inst 0. Okay, so as to just indicate that it's an instance. You can write your own name, no problem. clk comma q. That's it. Initial, begin. After that बोलो dump file cntr.vcd dump vars one. After this clock equals to 0 initially, let's say. Repeat, let's say 20 times by a delay of 2. clk equals to complement of clk and module. Alright, let's see if this runs. Need to select this. Syntax error at 15. Test bench, okay. Repeat 20. What is the syntax error? Oh, you should not give semicolon after repeat. In paper also I will put some those, deliberately I will put some errors. Okay, you will have to determine. Okay, I didn't get the output, so let's see why it is not. Okay, I should initialize this to 0, otherwise it may not run. So there are some subtle techniques which you should remember, because not remember, but you should like guess why we are doing this. because see, for example, I've simply specified that q as 0 there. Otherwise, what if I didn't specify that 0? As I said, initially it will take don't care. Even if you increment don't care, it will be don't care. So, net problem here. And you should actually, you should be intelligent enough. You should be like, no, you should capture where to give that 0. You can't initialize that q equal to 0 here, just because this is an instance. An instance can't have this output as regs. They must be wires. But if then how to specify the initial value? We are specifying that as 0 in the flip-flop definition itself. So that is how the trick works. What I am saying is this q, initially it will be of any value. It may be don't care condition. Even if you increment don't care, it will be don't care. We don't want that. So what I am doing is I need to specify the q some value. Let's say it's 0. I can't specify that here in the main module. Why? Just because if you specify, we can't use this instance, because that needs, we can't assign the value to reg if you create an instance. It must be wire. So what we are doing is we are simply defining that q equal to 0 in the initial state itself. I mean in the flip-flop definition itself. Oh, it's not loading. Run it again. Alright, yes, I am getting the value. So it's a down counter. Why? Positive is triggered, na? Oh, the QB. Achha, I have taken Q as output and given. I didn't give the complement of Q, na? That's why it's a down counter. Oh, it's okay. So if it has to be up counter, then we have to complement that, right? Q has to be complemented. So what I will give is complement of this. That's it. Yeah, good. You should not complement everything. Complement only the input, right? Should get this value, this output. Okay, go for implementation of up counter, down counter using behavioral modeling and structural modeling. Quick, go for it. Those who are done with the T-flip-flop implementation, go for JK column. हमने भी got the value for the previous वाला behavioral का कितने लोग का हो गया behavioral 1 2 3 ओ behavioral हो ही बाकी का अच्छा यहाँ पे कितने लोगों के पास लैपटॉप नहीं है मतलब जनरली आस्किंग डोंट ओन अ लैपटॉप 1 2 1 2 2 actually I was planning to okay I am planning to conduct open book, open internet examination for the entrance. So you can very well browse through internet. You can very well bring as much books you can bring cheats, no problem. But you can't discuss it. I mean, yes, of course you can chat on mail and send on WhatsApp that what will be this answer and all. But the thing is like you can't copy format like as it is. That will be plagiarism. Okay, then you will be caught. You can't copy from the person where he will be sitting in front of you or anywhere between you, because that will again be a plagiarism. If you copy from the internet and change the variables, let's say एक element भी लिख दिया, that is again a plagiarism, but with different name. That is called as an intelligent plagiarism. So again, that is not allowed. I'll give 0 mark. So anyway, if you are even if you are being provided the resources, unless and otherwise you use your brains, you won't be able to do that. So for that purpose, I mean the paper will be that kind. Like you won't be able to find out the internet. So how many of you like okay with it? Like, अगर नहीं बोले तो फ्री में रखूँगा तो इससे बेटर है कि हाँ ये लो. Like you can bring your laptop. See, I will tell you 2 problems with it. What I can do is I may specify the code in the paper. I may ask you to debug that. How tedious it would be without a compiler. Think of it. Now assume that you are having a laptop, but I will give some design problem. At least you will be able to compile something and get the output. Isn't that a good thing? I mean, both of them are having their own pros and cons. मतलब मरना तो है, कैसे मरना है आपको? हाँ? Only? Are you learning digital electronics partly or completely? So the course is like the end sem examination is meant for like full पूरा का पूरा exam. Right from day 1 introduction to whatever we are going to cover this just before the exam. So I'm just worried about people who can't find it. But it's optional. I mean, you can't bring your laptop, you can't, and you need not bring your laptop. It's up to you. If you bring your like, laptop or online resource, if you are running it, the advantage is you can simply specify the URL. Okay, on this URL use the output. Again, I will have to, it may happen that you go to your place, change the code there, and when I open the code, I will see the modified code. But again, I will see the date modified code, so you can't do those things. Okay. Yeah, go for it. Will you tell me, okay? How to proceed? कैसे मारना है बताओ? See, the thing was like you were getting initial EF just because like I'm actually complement the thing and then giving the input. So what you can do is you can define this complemented. Okay, let's see how to do that. Uh, okay, I'll avoid this. You can change the inputs in such a fashion that if you simply remove these complements you will get down counter. Okay, you might have noticed that you are getting for down counter it is incrementing properly, I mean it is decrementing properly, but for up counter it is like it is giving some initial EF values and then it is incrementing. That's because you are making the negation here. So instead of this, what you can have is you may define this QB terminal as separate in a T flip flop. Okay, like as a separate entity. Like you are having the uncomplemented input here, output here. You can specify complemented output there, QB, which is nothing but the. So let me say assign you can specify this QB as complement of Q here itself, but not directly. You will have to specify that assign statements and all. If you do that, then you will get the output. Like it is incrementing properly, but initial states won't come there. So I am just not modifying this. So this is now down counter. Get such kind of output. All right. So now tell me this name for this 4-bit bolo 4-bit ripple or asynchronous. Up counter using T flip flops. That we can't specify in the behavioral. We don't have to. Alright. Everyone got this? Counters? Any doubt till now? Is it okay? Alright. Let's go ahead. Now, see some. I'll take a part, like if you know that part, then you can design anything in any sequential circuit. So that is nothing but a state machine. Like state machine, if you know what the next state would be, corresponding input for what corresponding input, what would be the next state and corresponding output, then you can design any FSM or any design in digital design you can implement. So what we'll do is we'll go for design of an FSM. Okay. Let's take any example. Let's take an example. So I'm taking an example of, say for example, you want to detect this sequence detector, or better way I will write some, say this is S0, S1, S2. Assume that we have 4 different states and the transitions are something like this. Say if the input is 1, I'm specifying output as 0. And yeah, look at this state diagram carefully. Alright, can you tell me what it is doing? Anyone except Vaibhav? Okay, I told you this. Okay, except Divish. Or what is this doing? Look at it very carefully. हाँ, confidently. कौन बताएगा आंसर इसका? Look at the circuit very, look at the state diagram very carefully. What is it doing? बोलो बोलो. Yes. So as you know, some people have said it's a 110 sequence detector. Look at this very carefully. If initial state is S0, if the input is 1, the output is still 0, and it goes to the next state, by the way. If the input is 1, again it goes to the next state, but still the output is 0. Again, when it is in state S2, if the input is 0, then it gives the output as 1, and then it goes to the next state. That means what? After having 110, only after detecting 1, 1 and 0, you are getting the output as 1, not otherwise. Now this is regarding this, straight flow. What about the next? What the other vectors are doing? Say for example, instead of after detecting 1, you got 0. After detecting 1, you got 0. That means the sequence is broken. We wanted 110, but we got 10. That means it went to the previous state. to detect or to welcome when the next one appears. Now it is in, let's say it is in state 0, S0. We wanted next state to be, we wanted the next input to be 1. What if the input is 0? I mean initially it was 0, still the next input is 0. Again the sequence is broken, we wanted 1, so it will remain in the same state, but still the output will be 0. Let's come back here. So this is about S1, S2, no S0, right? Let's come to S2 here. S2 पे कब आएगा यहाँ पे? जब 1 सक्सेसफुली डिटेक्ट होगा तभी ये S2 पे आएगा. नाउ इट इज लाइक 1 has been detected. What do you want next? 0. But say for example we didn't get 0. Instead of that we got 1. So 1 is still valid sequence. So it will retain the same sequence, but the output will still be 0. So input, if we get 1 again, output will still be 0 and it will retain the same state. We have seen this. Come to S4. In S4, now when it will come to S4? When successful 1 0 has been detected. After 1 1 0 has been detected, okay, it will be in S4. Now after S4, if the input is 0, now I mean it is resetted, na? So if the input is 0, where should it go? I mean I want next 1 to be detected. Anyway it is, if we are getting 0, then it will go back to the previous state. If it is 1, if we are getting 1, that is a valid sequence, and that is a valid starting point of detector sequence. That is, we wanted 1 1 0, na? That is a valid starting point, so it will go back to the first. Is that okay, everyone? Everyone got this? I have explained this. Yes, please. फिर से explain करना. Okay. See, what I am saying is, I ask you what this state diagram is doing. If you look at it carefully and assume that S0 is the initial state, check when it is jumping to the next state. When is it jumping to the next state? When the input is 1. And what is it doing? How will it get to know what it is doing? We will form a truth table saying that, okay, if S0 is the initial state, if we give input as 1, it will go to the next state, but the output will be 0. I will keep the output as 0. That means it won't do anything. Now I am in state 1. When will it come to state 1? When 1 has been successfully detected as input. Next, we are at state 1. If 1 is given as the input, it will go to the next state, but still the output is 0. When it will come to state 2, when it has come from state 0 and state 1, then it will come to state 2, right? State 1, 0 से 1, 1 से 2, ऐसे ही travel होगा, arrows देखो. That means what? It will come to state 2 only 1 and 1 has been detected sequentially. Now we are at state 2. It will jump to next state, only 0 has been detected, unlike the previous one where 1 has been detected. If now it is 0, then the output is 1. That means what? When it will come to S4, when 1 has been detected, 1 has been detected, and then after that 0 has been detected. Till that point the output is 0, and at the end, I mean after which 1 1 0 has been detected, it will make the output as 1. So this is about the state flow. This other way around, it's a binary state machine. What if instead of detecting 1, we detected 0? We wanted 1 1 0, but we have detected 0, so it should retain the same state just because it's not a starting of any valid sequence. It is retaining 0 when the input is 0. Output, we should not give any output just because we wanted 1 1 0 to be detected sequence. So both the cases are covered. When the input is 1, input is 0. Come to state 1. We have covered the case when the input is 1. Let's cover the case when the input is 0, when the initial state is S1. Now we are at S1. We have considered the case when the input is 1, but we didn't consider the case when the input is 0. That means what? 1 has been taken care of. I mean, if you come to S1, only input has been 1. After that, if 0 comes, what will happen? Sequence is broken. After 1, it is coming 0. We wanted 1 1 0. It has appeared 1 0. Sequence has broken. It should go back to the initial state. So it will go to the initial state when it is at initially at S1 and input is 0. It will give the output 0 and go back to the previous state. Is that okay? come to S2. It will come to S2, the present state will be S2 only if 1 and 1 has been successfully considered as an input. Now we are expecting 0 to be there, but say for assume that 1 1 1 has been detected, triple 1, but you know the next these two ones are still the part of array sequence 1 1 0, so it will retain the same state waiting for the next 0 to appear. Is that okay? And so on. Everyone got it? Okay. Now we need to design this in Verilog. Okay. So if we, what is the usual procedure that we follow? What is the usual procedure that we follow? Sequence detector. बोलो. Sequence detector हमने सेमेस्टर के ये सेशनल के बाद लिया है. बोलो. Except Vaibhav. Sequence detector कैसे डिजाइन करते हैं? What is the procedure? Tell me. Sequence detector पन्ने पलटो पन्ने. Sequence detector प्रोसीजर क्या है? पहले तो स्टेट डायग्राम ड्रॉ करेंगे, उसके बाद we'll determine. Yeah, I mean first we'll have to determine the number of states, then number of flip flops required, then which flip flop to use. I mean we can use any flip flop. You remember? We can use any flip flop. उसके बाद we'll determine what inputs are required for desired output, and accordingly we will prepare the inputs, the present state and the next state. You remember those tables? The present state and next state. I'm seeing some blank faces. पन्ने पलटो, सब आएगा एग्जाम में, बता रहा हूँ अभी से. ऐसी पढ़ाई कोई काम की नहीं है, पता है क्या आपको? मतलब आपने जेई अच्छे से फोटो से प्रिपेयर किया हुआ है, आपको अगर मतलब पता भी होगा, नाउ इट्स लाइक वेरी वेट एंड वेरी फ्रेश. अगर आपको कंसेप्चुअली अगर आप नहीं पढ़ोगे ना तो आपको रिमेंबर रहेगा ही नहीं. टेक माय वर्ड्स. अगर आपने कंसेप्ट से पढ़ा है, लाइफ टाइम यू विल रिमेंबर. यू जस्ट नीड टू ब्रश इट अप. ओके, आई मीन एग्जैक्टली आपको रिमेंबर नहीं रहेगा, पर यू हैव, इवन इफ यू रिवाइज स्लाइटली विल कम टू नो. बट अभी क्या 15-20 दिन हुए, 15-20 दिन पहले पढ़ाया हुआ पार्ट अगर आपको पता नहीं, मीन दैट्स ए रियली सीरियस सिचुएशन. Alright, so if we go with the structural design of this state diagram of 110 state sequence detector, it will be very difficult. I mean we'll have to specify first the flip flop, different flip flops, then we'll have to instantiate it and then make the connections. That what we'll do is, we know its behavior. What is its behavior? It will jump to the next state only if certain input sequences are detected. Okay, let's do it. So what we'll do is, there is a provision to define some variables. Like we are defining variables in Verilog, so we can define variables in Verilog using what is called as parameters. It's not necessary to define this, but say for example it may be like, for our understanding we may say that, see what the computer understands as 0 as some state 0 0, S1 as some state 0 1, and so on. Say for example there are n number of states, then it will be very difficult to to figure out which state it is in. So better to put some labels there. Okay, give some labels that can be given using what is called as parameters. So these are like constants or labels. What I can do is 0. I'll defining as parameters as 0. I mean in binary it is 0 0, as 1 as 1, and so on. S3, well, oh I missed S3. Okay, so it is S3, just avoid this. Okay, so now S4, it's S3, it's not required S4. Alright, S3 equals to, so what does this indicate? instead of specifying those binary numbers, I'm simply giving them labels. So it is better to understand the code, like it is jumping from S0. So while specifying the code, we won't specify that it is jumping from state 1 to state 2 and so on. Because say for example, there are n number of states, it will be very difficult to track. So let's label them. So labeling can be done in this fashion. And after this, what we can do is we can specify cases. We have seen cases. We can very well use that case. Like case, what should be the case? Case can be any of these states, right? So let's say it's a state. We need to check the state. If the state is S0, that means what? We are currently in that state. If it is at S0, what do we need to do? If it is at S0, what do we need to do? We need to detect what the input is first. If it is initially at S0, we'll have to detect what is the input. If it is 1, go to the next state. If it is 0, retain the same state. Then I can specify if what? In equal to 1, or I can specify in, because I just want 1 to be detected. If 1, the next state, that means the state which was there earlier, the state should be what? You tell me. As 1. When the 1 is detected, it will be as 1. Otherwise, else state below as, and so on. You got this? Understanding this? But wait, we didn't specify the output, right? We'll have to specify the output also, right? So if there are multiple statements in if, we need to specify begin and end. Okay, so how you can do that? Like this. So I'm just elaborating this as 0 part. So as 0, if in, I'll say begin, and I'll specify state to be S1, right? It will jump to first state. And बोलो output क्या रहेगा बोलो? Output is, see here, if the input is 0, output is still 0. If the input is 1, still the output is 0. Both cases the output is 0. 0 end लिखूँ यहाँ पे. After that else में again 2 statements. बोलो यहाँ पे क्या बोलो स्टेट क्या रहेगा? Now what is the state? When it will come to the else part, when the in is false, that means in is 0. When in is 0, what it is doing? It is retaining the same state. State will be S0. S, what is the output? What is the output? 0. Now you write and after this you should write end case and so on. You got this syntax? Everyone got this syntax? Sure? Let's go for the coding. Open it in new page, fresh. I'll just specify an example. So it would look something like this. Okay, I can specify the parameter using the keyword parameter. See here. So what is required? A state machine. I have simply specified that. What are the inputs required? Now wait, it's a sequential circuit. So this will happen for every clock, isn't it? It's a machine, state machine. I mean, if we simply put everything in block, everything in a single block. If I put everything in a single block like this, ये पूरा इसके अंदर है. Okay, and When should it operate? When the input appears, but this should happen, no, it should be independent of clock. Okay, it should retain, I mean it should constantly check for the input to be 0 or to be 1. When it will check? When it is actually triggered by a clock. So clock will be there, that's it. I mean the input will be only be a clock, and it will jump from one state to the other, and states will be appeared as Q. Alright, so इसके अंदर ये है, तो आई एम राइटिंग द कोड समथिंग लाइक दिस, यू राइट बाय योर ओन. So the input is clock, and then the output is again a, see this out is different from this. Okay, I'll write it. This output is nothing but, okay, I'll write this directly in the coding. Yeah, let's define module, give some name. It's a detector, na, 110 detector. So let's say it's a sequence detector, duet. Input clock, output Q, that's it. Input clock, output. Well, apart from clock there is also in, there is also out. So in, out. Now output is again how many bit number? Output is only 1 bit. Okay, only 1 bit. What about Q? Q is nothing but the state, or I will better write it as state. So state is again an output state. बोलो कितने states है? 4 ना? 1 2 0. Is that okay? After that, always @pos age of clock now. We need to define the state. Okay, first we'll have to check the state, where in which state we are in. So case state. So state may be any value. So as I said, I may specify directly at 0 1 2 3, or I can define parameters. I'm just avoiding those parameters. If it is 0, now we are in state 0. What should I check for? Input. Yes. If बोलो in, यहाँ पे क्या लिखूँ? Begin ना? Begin state. If the input is 1, it is going to the next state, na? State is 1. And output कितना है? 0. And अब ये सिर्फ if का end हुआ है ना? Else indent it properly for better visualization. बोलो, ये कॉपी पेस्ट कर लो यहाँ पे, बिगिन एंड.